In this session, we'll talk about recursion, particularly the behavior of the stack. We will trace a method called factorial, and we show the importance of the stack in this process. Before we go and jump into recursion, let me introduce the concept of a stack. You're probably familiar with the notion of stack, a stack of books, a stack of pancakes, a stack of something else. We will talk, as a matter of fact, in a different video about the data structure stack. But for now, I just want you to understand that the stack is a data structure that is used in order to store recursion, particularly activation records. The stack has this characteristic of the first in, last out. In other words, the first element that got pushed, it will be the last one to get out. Some authors, they talk about the opposite. Last to get in will be the first one to get out. So don't be surprised if you see a couple of those variations, but don't worry, all of them, they're referring to the stack. When you add elements into the stack, you always add them to the top. For example, here we're adding a couple of items, always in the position where the top indicates. We're gonna add 6 values here, so you can see the behavior that the first element to get in will be the last one to get out. This process of adding elements, it's called push. We say that we push an element every time we add an element at the top of the stack. When we remove, we always remove what is on top. Notice that the first element that got pushed will be the last one to get out. Similarly, the last one to get in will be the first one to get out. This process is called pop. Pop is the process of remove the element that is at the top of the stack. The first element that got pushed will be the last element to get out, pop. In this order, we respect the first in, last out, also known as philo. Let's trace factorial, a recursive implementation. Factorial is a well-known method in computer science, very useful in many mathematical aspects. A factorial of a number n is the product of all the consecutive numbers from 1 all the way to that number n, and is denoted by this exclamation mark. Factorial. When we perform an n factorial, it will calculate by n times n minus 1 times n minus 2 all the way to 1. Make sure you don't include 0, otherwise the product will be 0. For example, 5 factorial is 120. How do we know that? It's because 5 times 4 times 3 times 2 times 1 is 120. The method looks like this. We're going to call it f for factorial, but basically when we arrive to 0, base case, we're just going to return 1. Why 1? Because 1 is the number that does not affect the product. The recursive case is composed by the number n that we're currently using times the self-call method for factorial, f. In other words, we're going to self-call ourselves every time we call this method, removing 1. Let's test this by using factorial 5. We're expecting 120 as we see this. Notice in the left-hand side, we have the main. Inside of the main, we have the method called factorial of 5. In the right-hand side, you can see the copy of the method somewhere in memory, f, that will take a value n as a parameter. And in the body of the method, you see the code that we just explained. When you call f of 5 from the main, f will invoke the method that is somewhere stated, with n the value of 5. So let's trace it. Once you get in the method, it will check if n happens to be 0. In this case, is 5 equals to 0? The answer is false. So we simply omit the entire if statement and we jump to the else. And I want you to pay attention what is going to happen here. When you arrive to the else, n will be 5, of course, and we'll multiply fn minus 1. Now, at this point, n is 5, as we know, but we're going to remove 1, so that will be 4. In other words, we're going to call the method f of 4, and this line, factorial 4, will be executed once we execute f of 4. So notice that we're going to return a number in this method, and we're still not going to do it until we arrive from f4. When you call f4, it will self-call f. This time, When you call f, n will be 4. Again, we're going to trace, checking if the condition is true. Is 4 equals to 0? And the answer is false. So we will omit the actual if statement, and we're going to jump into the else. At this point, we're going to call return n times f of n minus 1, which is 4 times f3. We will return a value, an integer, but not until we arrive from the return statement of f3. Again, self-call f. This time n will have the value of 3. We're going to check if 3 happens to be 0, which is false. So we will omit this statement and we jump into the else. Again, we execute the same thing. This time the value of n is 3 times f of n minus 1 will be 2. And we will return back from f of 2. When you invoke f of 2, in this case, n will be 2. Next step is to check if the condition is true by asking, is 2 equals to 0? This is false. So we omit the if statement and we jump to the else. We're going to execute n times f of n minus 1. In other words, 2 times f of 1. We're going to return a value, but not until we arrive from f of 1. Let's see what f of 1 is. Here n is 1, and we're going to do the same thing. We're going to check if the condition is true. Is 1 equals to 0? That is false. We omit the body of the if statement, we jump into the else, and we execute the line of n times f of n minus 1, which is in this case 1 times f of 0. When you call the method f0, check what's going to happen. At this point, n will be 0. So we will arrive to the if statement, and we're going to check this condition by asking, is 0 equals to 0? And the answer is true. So we arrive to the base case when we need to stop. At this point, we're going to read the following. Return 1. You might expect, what is the 1 at this point? And I want you to pay attention in the following comparison. Do you remember the stack that we showed you at the very beginning? This part will play an important role when we arrive to the base case. Check this out. The last element that got called is this activation record, is what is on top of the stack. Check out these colors. This will represent what is in the top of the stack, and the rest is the other calls that we basically call them through the whole process. This last statement was the very first execution that we arrived. When we push everything into the stack, recursively speaking, was the very first method that we call after we invoke f from the main. So at this point, you can visualize that these activation records are stored in memory with important information. There is data here and valuable information that we need to pop. And every time we pop will be a calculation. In reality, we only care about these return statements. Remember that we're waiting from previous activation records, from previous methods, to give back that value. So these activation records are stored in actually the stack. In this particular order. In the left-hand side, you can see the stack, first in, last out, how they get called. In the middle part are actually the illustration about how we call the methods and what they're waiting for. Notice that each return is expecting an input from future calls. F4 is waiting for F3, F3 is waiting for F2, F2 is waiting for F1, F1 is waiting for 0. In the right-hand side, notice that those are the calls when n was 5 all the way to 0. So right now, we arrive to the base case when we need to return 1. The question is to what? When we return 1, it will return 1 to whoever calls it. And is in this case, when f was 0. So we're going to pop 1 and return the value of 1 whoever calls it. So we're going to change f of 0 now to 1. We already know it's going to be 1. So we can simply just multiply 1 times 1. Which is 1. So we're going to return 1 to whoever calls this guy, which was f1. That means that we're going to pop our previous value f0 and return the value 1 to whoever calls it. And now we're going to make the multiplication. 2 times 1 is 2. So now we're ready to return the value of 2, an integer, to whoever calls us, which in this case was f of 2. We substitute the value of the returning value of f2, which is 2. 3 times 2 is 6. So now we have another value that we're going to return, which is 6. Who calls this? When it was f of 3. Now we have the value of f3 will be 6. So we just simply multiply 4 times 6 is 24. Let's return 24 to whoever calls us. So it was in this part when n was 5, we called f of 4. We simply multiply 5 times 24 is 120. When we make this calculation, we're going to return 120 to whoever calls you. It happens to be that was the very first method call, the very first activation record store. Now we can return this to the main. Notice that at this point, now we have f of 5 is 120. And this is how we got calculate.